This video will introduce you to the idea of using two triangles to solve problems involving trigonometry. In the first example, they tell us that a firefighter on the ground sees the fire break through a window. They tell us that the angle of elevation up to the windowsill is 32 degrees and the angle of elevation up to the top of the building is 40 degrees. We also know that the firefighter is 72 feet away from the building, and they want us to determine the distance from the roof up to the windowsill. So if I'm looking at the picture, this distance from the roof to the windowsill is represented by that yellow line segment. For lack of something better, I'm going to call it D in my picture. And I immediately notice that that distance represented by D is not part of any right triangle anywhere, which is a little different for us and presents kind of a dilemma. We're going to tackle this dilemma by instead looking or utilizing the two right triangles that are in the picture. So we've got a blue triangle that happens to be a right triangle and a green right triangle. I'm going to call the vertical distance on the green triangle x and that vertical distance in the blue triangle y. And if I were able to determine both the values of x and y, then I would be able to subtract in order to find that required distance. So that's going to be kind of my strategy here, is to find both of those vertical distances in the right triangles. So because these overlap, I'm going to begin by separating the two triangles. And the colors will be helpful to you if you have highlighters or colored pencils or colored pens. So this piece was y. In the blue triangle, that angle was 40 degrees, and that horizontal distance, the 72 feet. In the green triangle, I called that vertical distance x. Still the same horizontal distance of 72, but this angle had a degree measure of 32 degrees. Now the same trig ratios that we've been using all along still work. Tangent is opposite over adjacent, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. So when looking at these pictures, in both of the pictures, the variables represent the sides opposite. The 72 represent the sides adjacent. So the trig ratio that I'm going to use to solve these triangles is the tangent ratio. So in the blue triangle, I know that the tangent of 40 degrees is equal to y over 72. And at this point, I'm going to go ahead and dig out my calculator. If you need to pause the video so that you can dig your calculator out, go ahead and hit pause. But you need to be plugging these into your calculator as I'm working the problems on my calculator. Great, now that you've got your calculator, I'm going to go ahead and start by going home and checking my settings and just making sure that I'm in float 12 in degrees, which I am. If you need to, change your display digits to float 12 and your angle to degrees. Once I go and open up a new document, notice that when opening up that document, that degrees appears right here in the upper right hand corner, and that's just a little bit of added reassurance to you that you are indeed working in degrees. And I wanted to find the tangent of 40 degrees. And remember that even though I'm going to work with all of these digits in my calculator, I'm only going to put the first 4 of them down on my page. So 0.8390. And in order to solve, I'm going to create a proportion by putting that over 1. And then I'm going to go ahead and cross multiply. But again, remember to go up in your calculator, grab that 0.8390 number. That's the number, that whole number that we want to multiply by the 72, not just the 4 digits that we put on our paper. So 60.4151 Remember that y represented this vertical distance of that blue triangle here, or the distance from the firefighter's line of sight all the way up to the top of the building. Now I'm going to go ahead and do the exact same process, but this time for the green triangle. So the tangent of 32 degrees is equal to the x over 72. And in my calculator, I'm going to go determine the value of tangent of 32 degrees. So 0.6248. And once again, I'll turn that into a proportion by putting that over 1 so that I can cross multiply. And once again, when I cross multiply, I'm going to use the whole decimal display in my calculator, not just the rounded or the 4-digit decimal that I've put on my paper. All right, so maybe you see very clearly that that distance that we're looking for in the problem is just the difference between y and x. If that's not so clear, not so obvious to you, you could think about the distance d plus the distance x, or x plus d is equal to the entire distance y. So when you subtract x from both sides, distance is equal to y minus x. And again, in order to find this, I am not going to use these 4 decimal numbers, but I'm going to go back into my calculator and I want to subtract the 60 number. So I'm going to go grab that. And from that, I want to subtract the 44.99 number. So again, notice that in my calculator, I use the entire decimal display. So rounded to the nearest tenth of a foot, like they're requesting in this problem, 15.4 feet. Excellent. So there you can see pretty nicely how you can use 2 sets of triangles in order to solve a problem when one of the pieces that you're looking for is not the side in the right triangle. All right, let's go ahead and take a look at a second one. And number 2, I'll let you go ahead and read through that question because you're quite capable on your own. This one's a little bit trickier in that we actually have to label the diagram. It hasn't been done for us. So the angle of elevation from Alex up to the bird in the top of the tree. Remember that for all of your angles in elevation and depression, one of the sides of your angle must include a horizontal segment. So angle of elevation is going to be from Alex looking up, and that's the piece that's 32 degrees. Angle of depression is going to be from that horizontal piece looking down, and that degree measure is 40 degrees. And in this question, they're asking us to find the height of the tree. So I notice immediately that the height of the tree can be found by finding that purple vertical piece in the purple triangle plus the green vertical piece or in the green triangle. So that's what I'm going to be, those are the pieces that I'm going to be trying to find. The other piece of information you need to solve this problem is you need to know that Alex is exactly 30 feet away from that tree. All right, so I'm going to go ahead and draw my triangles separately. There's my purple triangle with that 32-degree angle of elevation, 30-foot horizontal piece. I'm going to call this piece X. And in my green triangle, I'm going to call that vertical piece Y. Beautiful. And now that I've isolated my triangles, I'm all set to go ahead and start to do some trig. So in the purple triangle, I notice that I'm dealing with the opposite side and the adjacent side. So I want to use the tangent ratio. And I'm going to go ahead and get the purple triangle all the way done before I do anything with the green triangle. So I want tangent of 32 degrees. So 0.6248. And again, I'm going to put that over 1. And when I cross multiply, just like I did before, I'm going to do that number, grab it, bring it down, that whole entire decimal times the 30. And then I'm going to move into the green triangle. So in the green triangle, y represents the side opposite my angle. 30 is the adjacent side. So again, the trig ratio dealing with opposite and adjacent is the tangent ratio. And once again, I'm going to go back to my calculator. And again, I'm going to use that whole decimal to multiply times the 30. And I'm being asked to find the height of this tree. The height of that tree is going to be the value of x from the purple triangle plus the value of y from the green triangle. And once again, I am not going to use these 4-digit decimals, but rather I'm going to go back to the calculator. I'm going to grab that whole 18.74 number. To that, I'm going to add the entire 25.17 number. And then the very last thing that I'm going to do here in my problem is round it to whatever I've been asked to round to, which in this case is the nearest tenth of a foot. So that tree to the nearest tenth of a foot is going to be the 43.9 feet. All right, so just by their very nature, these problems are more complicated, more complex than the other applications problems that we've looked at before. But really, it's just taking two of those and kind of combining two of those questions into one question. On the next page, I do want you to take a few minutes and summarize the key ideas and important understandings. But if there are two problems on the next page, I want you to not do the one with the apartment window, so you can omit the one with the apartment window if that one is there. But you should take a look at and see if you can apply what you've learned to the flagpole question. All right, and as always, thank you for the gift of your time. If you have questions, of course, I'll be happy to answer them the next time you come back to class.